In this problem, I need to determine if there's a connection between the type of school that a person attended as a child and college major. So we have a table of results which gives the counts of the number of people in each category. So because these are counts, and because we're looking to see if these two variables are independent or not, and the variables are the college major and the type of school attended as a child, then we're going to conduct a test of independence. So I have, for example, 56 people who major in liberal arts and who went to public school. So that's how we read the table. And I'm going to take this information and go to the next screen. Okay, so my first step for completing my test of independence is I need to enter the data into the calculator. This is not going into the lists like we normally do. So we need to enter the data into the matrix. And to do this, you start by pressing second and the X to the -1 key on your calculator. That'll bring up the matrix menu, and you need to navigate over to edit. So you can either press the right arrow twice or go around the other way, press the left arrow only one time. But we need to be on edit. When names is selected, then this looks basically the same. It's easy to pick the wrong thing, and you need to go over to edit because we need to enter information. You may not have the number of rows and columns here. It may be blank altogether. You can see a lot of mine are blank. Or it may say 2 by 2, something like that. That can be edited in the next screen. So you just go ahead and select matrix A. Don't skip A. We really want to use matrix A. Makes life a lot easier. Okay, so now once I'm here, I go ahead and press enter in order to get to the next screen. And I start by entering the number of rows and then the number of columns. So right here is rows, and here is columns. So always rows first and then columns. And you'll see it set up, so you can compare it to your data and adjust accordingly. And then you just type in the data. Every time you type a value, then you press enter in order to go to the next slot. And you fill in all your data. If there are numbers in here already, you just type over them and there's no problem. So now we've got our data entered into the matrix, and so I'm going to press second and mode to exit out to my regular window. And now I'm ready to start actually conducting the test. So first I'll give my null and alternate hypotheses. My null hypothesis, I'm just going to say whatever my two variables are. In this case, it's type of school attended and college major. I'll say that those are independent. So the null hypothesis is always saying independent. And the alternate hypothesis then is going to say just the opposite, dependent. So those are my null and alternate hypotheses. Then I'm going to run a chi-square test. We already have our data in the matrix, so we're ready to do this. And to do this, I go into the test menu like we normally do, press stat, right arrow twice, gets you over to tests, and then scroll down until you get to C, which is the chi-square test. The next one is a chi-square goodness of fit test. Let me move this a little bit so you can see. All right, so we've got a chi-square goodness of fit test. Don't use it. Just the plain chi-square test is what we want. It's the chi-square goodness of fit test is going to ask you for other information that you're not going to have. Okay, so there we go. And now we have our chi-square test. You have to love this one because there's really nothing to do. You have your observed matrix is A. We already entered the data in there. That's why we want to use A, because it's already set up for this. Expected values, matrix B. When the calculator conducts the test, it's going to fill that in for you. So you don't need to calculate the expected values. In the book, they tell you to calculate them. You don't need to. The calculator does it for you. So just leave that as B and skip over it. You want to change the color, change the color. And then you can either choose calculate or draw. Now if you choose calculate, that's going to take you to this screen. And if you choose draw, that's going to take you to this screen. So just whichever one you prefer. If you want the degrees of freedom listed, choose the calculate. If you want to actually look at the distribution, choose draw. And either way is fine. So how would I calculate the degrees of freedom if the calculator were not doing it for me? Let's take a look real quick. I go back to my data and I look at the number of rows, which is 4. And I take the number of rows minus 1 and I multiply it by the number of columns minus 1. So for this case, we have 4 rows and we have 3 columns. So this gives me 3 times 2, which gives me 6. There you go. So the calculator was right, which is good. So we have 6 degrees of freedom, and I have my test statistic, and I have my p-value. And the original problem said to test at the 0.05 significance level. So let's go to the next screen and see what to do. So now I need to decide whether to reject or not reject the null hypothesis. So to decide whether to reject or not reject the null hypothesis, I compare p to alpha, just like we normally do. And in this case, alpha is larger than p, and that tells me to reject the null hypothesis. So then I need to write a statement about the claim. So what does this mean? The null hypothesis said that the variables were independent, but we are rejecting that. So we think the variables are dependent. So my statement is going to reflect that. So here's my statement. The data indicate that the type of school attended as a child and college major are dependent variables. And that's the end of that problem.